Think about this for a second. A cow spends its entire day eating green grass, drinking plain water. Nothing white goes in at any point. And yet somehow, what comes out is perfectly, brilliantly white milk. There's no white ingredient anywhere in that process. No white food, no white water, nothing. So where does the white actually come from? The answer has nothing to do with what the cow eats, and everything to do with physics happening inside every single glass. Most people never stop to question it. Milk is just white, the same way the sky is just blue, or grass is just green. It's one of those things you've seen your entire life without ever wondering why. But here's what makes this interesting. White isn't actually a pigment or a dye. You can't add white to something the way you add food coloring. White is something your brain perceives when light behaves in a very specific way. And inside a glass of milk, that behavior is happening on a scale most people would find genuinely hard to believe. Milk looks simple, but it's actually one of the most complex liquids you'll ever drink. It's not just white water. It's a dense suspension of thousands of different particles all floating together. Fat globules, proteins, sugars, vitamins, minerals, and calcium. The two most important for color are fat globules and a group of proteins called caseins. Now these particles are almost unimaginably small, most of them measured in micrometers, thousands of times thinner than a human hair. You can't see any individual one. But here's the thing, there aren't just a few of them. There are billions of these particles packed into every single glass, suspended throughout the liquid and constantly moving around. For comparison, think about a glass of plain water. Water looks completely clear because water molecules are so tiny and so uniformly spaced that light passes straight through without hitting much at all. It just travels from one side of the glass to the other, almost undisturbed. Milk is a completely different story. When light enters a glass of milk, it immediately starts colliding with those billions of suspended fat and protein particles. Every single collision scatters the light off in a random new direction. That scattered light then hits another particle and scatters again, and again, and again, potentially thousands of collisions before the light finally exits the glass. This process is called Tyndall scattering, and it's the reason milk looks the way it does. Now here's the crucial part. Sunlight isn't actually white. It's a mixture of every color in the visible spectrum combined together, all of them traveling together. When all those colors scatter equally off the fat and protein particles inside milk, they all bounce back toward your eyes simultaneously, still blended together in equal proportions. And when every color of light reaches your eyes at once in equal amounts, your brain interprets that combined signal as white. It's the exact same reason clouds look white. Clouds are made of billions of tiny water droplets, each one scattering sunlight in all directions, mixing all the colors back together and sending them to your eyes as white. Milk is essentially doing the same trick, just in a glass on your kitchen table. Skim milk actually gives you live proof of this in action. When a large portion of the fat globules are removed during processing, there are fewer particles inside the liquid to scatter light. With less scattering happening, the colors don't mix back together as completely, and skim milk takes on a faintly bluish tint compared to full-fat milk. The less fat, the less scattering, the less perfectly white the result. It's the same physics, just with fewer particles doing the work. Here's something that surprises almost everyone. If you could somehow remove every single fat globule and casein protein from milk, strip it right down to just the leftover liquid, what remained wouldn't be clear or white. It would actually look faintly yellowish green. That subtle tint comes from riboflavin, also known as vitamin B2, which is naturally present in milk and carries its own slight color. The only reason you've never seen it is because all those billions of scattering particles completely overwhelm it, bouncing white light back to your eyes long before that faint tint has any chance to show through. The white is so dominant, it hides the color that was always there underneath. So milk isn't white because of any white ingredient. It's white because billions of invisible fat and protein particles scatter light so thoroughly that every color bounces back to your eyes at once. The same trick that makes clouds white, happening inside your glass every single morning without you ever noticing. If this made you think twice about something you've seen your whole life, hit subscribe. This is FactorFume, and there's a whole lot more of this kind of thing coming.